Hello Algebra 1, this video lesson will explain how to solve compound inequalities. Let me show you what I mean by a compound inequality. Here's a question where you would have to do that. You are looking at a sketch right out of our textbook of Mount Rainier in Washington State, which evidently, according to the textbook, is a little more than 14,000 feet tall. But it can be divided into sections. The top section here is called the glacier section, and then in here, this is called the alpine meadow region. I guess sometimes it's grass and sometimes it's snow. And then in here is the section called the timber region. I'm imagining this is the area where logging companies would be allowed to go in and take trees down. And then below here, in this section, might be the place where people are allowed to live. Each of these is a separate section. So a compound inequality helps you to talk about cases where you're trying to measure something that's in between two different boundaries. Later in the video, we'll also talk about situations where you're trying to measure something that's outside two different boundaries. But let's start with just in between. So here they're talking about the timber region being one of those and the alpine meadow region being the second one. Well, here is how you would actually write an inequality for the timber region. And what this is saying is that y, let's say y is the altitude or the height, is less than 6,000 feet, but greater than or equal to 2,000 feet. Less than 6,000, greater than or equal to 2,000. Ah, that's right. That is the timber region. The alpine meadow region here, by contrast, is less than 7,500, but greater than or equal to 6,000. Is it? Yeah. So there, 7,500, 6,000, right in here. You're right. That is the alpine meadow region. This is the way you write it. Let's start with some examples of kinds of questions that you might be asked. First one here, write an inequality that represents the set of numbers and graph it. What would the inequality look like for all the real numbers that are greater than 0 and less than or equal to 4? Well, greater than 0, x is going to stand in for all those numbers. X is greater than 0, but it's less than or equal to 4. Notice that x is in between these two, just like some of those regions on Mount Rainier are in between two altitudes. X is in between two values. This time we're looking left to right though. And if you had to graph it, you'd make a circle at 0, just like if we had covered this up for a second and imagine we're just looking at 0 as less than x, we would have made a circle, what we've sometimes called a donut, at 0, and we would not have shaded it in because that's not underlined. And we would have said x is greater than 0, so x is to the right, and we would have shaded this way. And if we had done just cover this up for a minute, just looked at x is less than or equal to 4, we would have made a circle at 4, but this time we would have colored it in because it is underlined this time. And this time, because x is smaller than 4, we would have shaded this way. Well, notice if you do both those things, you end up with shading in between two boundaries. Sometimes people write it as two separate inequalities. X is greater than 0 and x is less than or equal to 4. It doesn't matter if you want to write it this way. This tends to be the way that most people in most math classes write it, and it also makes a lot of sense because it shows that x is between two boundaries. Second question here. All the real numbers that are less than -1 or greater than 2. This time we're going to have a gap. X is either less than -1 or it's greater than 2. And when you graph that, you've got two different sections. First, we're going to make a circle at -1, just like they have. We're not going to color it in because it's not underlined. And we're going to shade where x is to the left, smaller than -1, and that's what they've done here. Then we're going to make a separate second circle at 2, and that's what they've done here. Again, we're not going to color it in because it's not underlined. But x is more than 2 means we shade to the right side, and we end up with this gap in between. Before I go any farther, let me talk about a situation where you actually might have a less than or greater than situation. Let's say that you're talking about a nursery school. you went to a nursery school, you would probably only find people who are 5 years old or younger, or they were adults. You wouldn't find any kids probably between the ages of 6 and 18. It wouldn't make a lot of sense that anybody between the ages of 6 and 18 would be at a nursery school. So that's a perfectly fine example where you have two different values that make sense and an or in between. Okay, that's it for that example. Notice though, before I go any farther, that and inequalities are always drawn as one shaded area between two boundaries, or inequalities are always two separate sections with a gap in the middle. So do remember that. Or are going to be gaps, and inequalities are going to be just one section in the middle of your number line. Now, put this together with the lessons we've had recently. How do you solve a compound inequality when it's not just x in the middle? Well, all they've done here is they've rewritten the question or the original problem. This is the same as that. Okay, well, to keep using the skills that we've been practicing the past few days, we've got to realize we've actually got two different inequalities. We've got this one over here, and we've also got this one over here, and we're going to have to deal with them separately. So you really have two problems to work on here. If I want to figure out how to get x by itself, I've got to move the 1 and also the 3, just like we've been doing all along. Move the 1 first, then the 3, because you've got to do work in the opposite order of PEMDAS when you're unwrapping. So move the 1 over by subtracting 1 from both sides. Same thing over here. Like I said, I've got two different problems. I move the 5 over by adding 5 to both sides. Once I do that, well, on the left, by subtracting 1, those canceled, and all I've got left on the left is 3x. 4 minus 1 is 3. Here, the 5's canceled, and all I have left on the left is 2x. 7 plus 5 is 12. Well, I don't want 3x on the left. I don't want 2x on the right. I just want x in both cases. So on the left, I'm going to divide by 3. On the right, I'm going to divide by 2. That's what I do. It's a little hard to read my handwriting. I apologize. But those 3's cancel. On the left, I'm just going to have x. Those 2's cancel. Here, I'm just going to have x. 3 divided by 3 is 1. 12 divided by 2 is 6. And I end up with two different inequalities, just like I had up here, but now I don't have anything except x on one of the sides. So I can say that x is less than 1 or x is greater than 6. Remember that or inequalities have gaps in the middle. So when I graph it, there's that gap. I've got stuff for a shaded area less than 1, and I've got a shaded area greater than 6, just like I should have had. Now, what about if it's not an or inequality? What if it's an and inequality? Well, in this case, example 5 out of the textbook combines two different issues that we've got to work with. What do we do when we've got x in the middle? And also, what are we going to do when we've got to move a negative by dividing by a negative? Well, let me walk you through both of these things at once. I don't want all of this stuff in the middle. I just want x in the middle. Otherwise, I don't know how to graph it. So I've got to move the negative 2, then I've got to move this negative sign. I move the negative 2 by adding it. But I add it to all three pieces. I think actually I've got this on this slide over here, sorry. I add it to all three pieces. By adding negative 2 plus 2 here, those cancel out. It turns out that adding negative 2 plus 2 here, those also cancel out. So on the left, I'm going to have 0. 1 also got 2 added to it, so that became 3. But here's the canceling I was looking for. Negative 2 plus 2, those went away, and all I have left now in the middle is negative x. But I don't want negative x in the middle, I just want x. So I divide all pieces by negative 1. And when I do that, 0 divided by negative 1 is 0. Negative 1 divided by negative 1 is just plain old 1x. And 3 divided by negative 1 is negative 3. But the second important thing to realize is I divided by a negative. The arrows have to change direction. So now notice x is in the middle, but I've got 0 on the left and -3 on the right. Now most cases you will not find the textbook, you will not find any math teachers, or most any math students after Algebra 1 writing things that flow in this direction. It just looks funny to most of us. We're used to having the arrows point that way. Well, notice that the textbook is going to do exactly that. And they explain it. They're matching the order of numbers on a number line by turning it around and putting -3 on the left instead of on the right, 0 on the right instead of on the left, and getting the flow going that way. I don't mind if you write it this way, but you will find after this year that your teachers won't. So this is the way it ought to be written. Now I'm going to have a shaded area in the middle, just like I always do with an and inequality. I'm going to have a circle at -3, a circle at 0. There they are, circles at -3 and 0. They're not shaded in because neither of the arrows is underlined. And the gap in between them is also colored in. This is the graph for this up here, or better said, it's the graph for the simpler statement down here. Okay, real life situation besides the Mount Rainier situation. Imagine you've got a friend, Bill. Hit the pause button and read this story about Bill. Okay, I'm going to assume that you did that and you've realized that you actually have two friends in this story, Bill and Mary. And Bill and Mary are, they live in two different places in the town. What's the smallest value, or in other words, what's the smallest distance that's possible between Bill and Mary, and what's the largest distance that's possible between Bill and Mary? Hit the pause button and think about those two questions for a second before I show you how to answer this. Okay, I'm going to assume that you did that, and that you are prepared not only to think about the question, but to write an inequality that describes this question. Well, just like in some of the word problems we've talked about before, I recommend a picture, a drawing. So here's that drawing that the textbook gives. Inside the red circle are all the, well, the red circle itself rather, that's all the different places that Mary could live, right? Because this is almost like the second hand on a clock, and it's whipping around here, and anywhere around here traces 2 miles away from the school. The blue second hand traces anywhere that Bill might live from the school. So they could be, like they're shown here, both at this angle from the school. It's also possible, though, that Mary's in this direction and Bill is as far away as possible over this way. And it's possible that Bill and Mary both live on the same line. Mary would just be from there to there, and Bill would be from here all the way to there. So, if both homes are on the same line, then think about it. This gap here is all that would be left between Bill and Mary, and so they would be 1 mile apart. If Bill lives all the way over here, as far as he possibly can from Mary, then he's going to live 2 miles this way, if he wanted to walk from Mary's house to his own house, 2 miles to the school, and then another 3 miles home. So together that would make 5 miles. How would I make an inequality that shows that? Well, this is how. Come into class and we're going to talk about this and make sure this makes sense. But Bill is going to live from Mary a distance that's somewhere between 5 miles and 1 mile away. Can't be any less than a mile away, can't be any more than 5 miles from Mary. Hit the pause button if you need to and read this. Of course, it's in the textbook too, and you can read it there. Come into class with questions, we'll talk this over, and we should be ready to talk about compound inequalities and other problems that I can give you once you get to class.